Good morning, everyone.
Can't hear Mark.
Can you not hear me?
Now I can hear you.
Oh, sorry, I was typing. Let's see, who else do we have? Oh, no Sage yet. I'll see if he's able to make it or not here. Okay, Sage's basement is flooding, so he's trying to take care of that, so he's not going to make it today. And I sympathize. Living in the Midwest, it's not fun. All right, let me find my window here where I've got the Etherpad, and we can keep going. All right. So, world of pull requests. This week we've got a couple of new things that look interesting. There's two different compression pull requests. Igor's, which has been kind of hanging out for a while, and Sage did a review and gave the thumbs up, and it's basically ready to go through QA. And that's exciting, is per pull compression settings in Blue Store. And then a little bit related to that, Piotr has one here for basically making compression a little bit faster by not doing unnecessary Adler-32 calculations. Since we're already doing the equivalent stuff ourselves anyway. So yeah, those will be good to see when those get merged. I'm kind of excited to see what we can get once we're compressing everything. Sage has another pull request here for reducing the amount of data we write when we dirty metadata. I haven't looked at that real closely yet, but hopefully that will help us in our quest for writing less data to RocksDB. I have not followed David's patch much here for reducing deep scrub impact on normal operations, but I imagine that there will be a lot of folks that will be very interested in that. So might be worth someone's time to check out if that's something that you're interested in. What else has been going on? Yeah, I haven't really followed too many of these other ones that were updated here. So I guess I won't speak too much to them since I haven't really been looking at them very closely. Oh, one thing that I will mention is that the FIO engine for Object Store got merged, so that's great. A lot of folks are starting to use that for doing Blue Store testing and other Object Store testing, so that's exciting. I have to rather embarrassingly admit that I have not looked at that yet, and I probably should. So that is good though that has been merged. And beyond that, I guess we've just got a whole bunch of stuff that doesn't have much movement yet. I think Sage is hoping to soon get the fast de-encode, re-encode, or encode, decode stuff merged, since that seemed like it's passing at least our kind of initial functional tests and performance tests here. So it needs to go through some more extensive tests in Tethology, but I think after that it'll probably get merged. So that's very good. Yeah. All right. So the other stuff that I've got for this week is we were seeing about a 50% regression in random read performance. And at first I thought it was something that we had done with Blue Store, maybe the sharding or something, but after going through and bisecting, it turns out it was when we merged making the async messenger default. And so I've been running through some tests with that. Increasing the thread count in async messenger seems to help, but it's not enough to kind of get us back up to simple messenger performance. And also, if you increase the thread counts too high, it actually makes the OSDs and the Ceph commands segfault. A GDB backtrace is a little bit strange. I'm trying to remember exactly where it was, but it wasn't something that was immediately obviously wrong. So I'll probably need to just sit down with Hanmai and have him take a look. But yeah, kind of in general, I'm trying to see if there's anything else that can be done here easily to kind of get around this. Otherwise, it'll probably just take a lot more deeper investigation. I guess from the one perspective, at least it's not Blue Store, so that's good, I guess. In other news, though, with Blue Store, we are seeing a lot better performance than we had kind of back in the Joule time frame. A lot of the work that's been done on encode, decode, and trying to reduce the amount of data that's getting shoved into RocksDB has paid off for smaller random writes. So that's good news. Really, the big remaining thing beyond just the async messenger stuff is sequential read, and we've kind of known for a while that that's been problematic, and I think that's something that we're going to need to focus on again. There are other things here that we can probably improve on. Just kind of general performance tweaks in various places. I'm still kind of interested in how much we're seeing locking slowdowns in the bitmap allocator, since that's, at least in my traces, has been showing up more lately now that we've kind of resolved other things. But overall, I think on the write side, we're actually doing really well now. We're typically faster than file store, or as fast at least. So I think probably sequential read is probably the next big thing that we need to figure out what we're going to do about. So that's kind of that. Yeah, so I guess that's kind of all I've got this week. Nick, it looks like you've got some new testing to share. Do you want to talk about that?
Yeah, hi Mark. Nothing majorly exciting. I just did a little bit of testing, just sort of running sort of benchmarks at different I/O sizes and just looking at how much CPU was used for a certain performance, and just sort of plotted that graph that I've put in the Etherpad. I just thought it might be useful for people when they're trying to size up sort of how much CPU power they need for a certain sized OSD node.
Cool. This is just with file store, right?
Yeah, it was, yeah.
Okay. It'd be interesting to see how those graphs look if you did BlueStore as well, just to see how much difference we see in them.
Okay, I'll see if I can. I mean, it won't be on the same hardware, but I can probably get something built up and do something similar for BlueStore.
Okay. Yeah, I'd be curious about that, just to see if, especially once we get the new encode decode stuff in, if it looks similar or not.
Okay.
I have a suspicion that BlueStore, well, maybe it's not at this point. Maybe it's not more CPU hungry, but for a while it was. Cool. All right. Anyone else have anything they want to talk about this week? Or questions regarding any of this stuff?
I have a question about async messenger, if you don't mind. So you said that it's still slower than simple messenger, but doesn't it use less resources than simple messenger? And are there situations where that would become a significant factor?
The only situation I'm actually seeing it slower is for random reads, small random reads specifically. And in fact, for like medium-sized random reads, it's actually a little bit better from what I've seen. So like the kind of performance graph that you see if you actually here on that Etherpad entry. Let me get that up on the screen. Give me a second here.
While you're doing that, the reason I'm asking is because my group did some testing of like hyperconverged, Ceph OpenStack storage, and the Ceph OSDs use up a ton of memory, and I was wondering if, and they open a lot of sockets and so forth, and I was wondering if simple messenger might lower the overhead.
Yeah, it's a good question. So one of the things that I did notice when I was doing this is that adding more threads to async messenger seemed to help. So take from that what you will. It might just be that we're not keeping them, or that we're waiting on them. I'm not totally sure. It doesn't help enough to get us up to the performance of simple messenger, but That is one effect I did notice. I've only kind of started looking into this though, so I haven't even done any kind of perf traces on it or anything to see if there's anything interesting going on. Well, I did want. Can you guys see the screen here?
It's jumping around a bit, but yeah.
Oh, sorry. So right now, do you see this throughput megabytes per second graph with BlueStore versus FileStore
Yep.
on NVMe? So if you look at the yellow and the green line, it's from master in late July versus this WIP denk branch plus some other patches I had added. That yellow versus the green line there, really what that's showing you is actually async messenger versus not async messenger. Even though there's all this other stuff also going on, really that's the performance difference there. And you can kind of see that at those middle I/O sizes from like 64 or like 128 megabytes or KB up to well, really up to kind of like large I/O sizes, the green line is higher, and that's the async messenger.
Mark, quick question.
Yeah.
This file store, sorry, that simple messenger one, right? You did it with bump up tcmalloc thread cache value, right?
tcmalloc thread cache is set at 128. It hasn't changed.
So I can remember for simple, for async, right, we don't need to do that. So that's definitely consuming less memory overhead than simple. Simple probably with 32 MB default will be performing lower than async.
Yes, I agree. With 32 it would be. But given that we're doing 128 as kind of the default now, it seems to me like that's where we should be testing them.
Yeah,
do you disagree?
It's the question that actually that been asked, right? So that overhead of the resources. So that actually tells that async is consuming less memory resources than simple, probably.
Yeah, I do have that data. I haven't looked through it yet, what the memory usage was, but I've got that.
Yeah. So Mark, I presume this is all small scale testing, right?
Yeah, this is basically like 4 OSDs per node on 4 nodes, so it's not real big at all.
Well, how many clients are you running? Sorry, I can't figure out them on my phone.
Yeah, this is 8 client processes with like an I/O depth of 32 per client.
Yeah, I have a suspicion that if we were running a larger scale system, we'd find out that the async messenger isn't slower on the random reads. So as we've been noting, like it's using fewer resources and fewer threads in a large system because Simple Messenger creates a bunch for every connection. But what Simple Messenger does get to do is it has one thread that just sits there and reads a socket and shoves data into the OSD, whereas the async messenger has to like switch through and do epoll and stuff to try and watch a whole bunch of threads or a whole bunch of sockets and then pass them off to a worker thread. So I think that's just a teeny bit more overhead on a single saturated like connection, but if you actually had incoming data from a bunch of different clients, we'd see that it's much more efficient.
Don't be so sure about that.
I mean, maybe not, but
it's not passing them off to other threads. At least not in any more. At least not any more than the kernel is passing off to waiting threads on blocking syscalls. I don't think.
Okay.
So this is kind of a scenario where we've got like pretty fast OSDs and not that many of them, right? So in this case, this is kind of testing how quickly a small number of OSDs can take in a fair amount. I mean, not a ton, but it's like, what would it be? And basically 64 incoming IOs, random read IOs at a time, or in flight at a time, I guess, per OSD, roughly. But is that right? Maybe I don't have my numbers right. Well, in any event, it's basically testing fast OSDs. So take that for what you will.
Can you put this graph up where we can get to the raw data?
The ODS file is in the Etherpad. If you are wanting that, do you want the FIO data, like the FIO output, or is the spreadsheet data good enough?
No, the spreadsheet's great.
Okay. Yep, that's in the Etherpad. Do you have a link for that?
Well, the Etherpad I'm looking for looks old.
Okay, just a second here. Okay, is that what you're looking at?
Yes.
Okay, the link is on line 164.
You might want to consider breaking the Etherpad up. It's got some really old stuff in it. Maybe archiving some of that would make sense.
Yeah, that's actually probably a good idea. It also makes the Etherpad really slow. Have all kinds of issues when the connection isn't real good.
You could break it up by year or something like that would be a big win.
Yeah, I think you're probably right. I'll see if I can do that here. But so anyway, Ben, to answer kind of your question about performance, so it's definitely not always slower. At least in this particular case, for larger I/O sizes, it actually looks like it's probably faster, kind of for these middle ones. And then for whatever reason below, at 64K and below, that's where it seems to do worse. But it's not necessarily because I guess the reason why it seems to do worse is because for whatever reason, Simple Messenger seems to spike back up in performance at that point. So I don't know. This is a trend that we've seen for a long time, where we kind of do oddly kind of badly in these middle I/O size ranges, and then at 64K with Simple Messenger, we kind of spike back up in performance and then kind of go down. So I'm not sure. It's interesting that we see this kind of difference in a pattern here, and there was some kind of like differences here when we changed TC-malloc settings too. Like if I remember right, when we went up to 128 megs of thread cache with TC-malloc, we actually saw some degradation in these middle I/O sizes. So I don't know if that tells us that Simple Messenger, like the allocator, is just having a lot of trouble with Simple Allocator, and that's why we saw that. And we're not seeing that with Async Messenger, but it's overall just kind of a little slower. But it is kind of interesting behavior. So there's probably more of a story going on here than we know right now.
Thanks.
Yeah. Sorry, I don't have a better answer for you. Hopefully we'll find out more as we look into this.
Well, so I mean, since we're on the subject, like, is there a difference, for example, in the way that they use sockets when recovery is going on? Because as I understand it, with a Simple Messenger, when recovery is going on, there's a lot of I think you folks are going to have to help me out here, but a lot of the sockets are not in use or something like that. I think I remember hearing, except when there's recovery going on. Is that true? Is there a difference?
There should be a lot of during recovery. I guess there would be a lot of communication happening. Certainly, right?
Not any more so than when regular I/O is happening. I mean, more so in that the cluster could conceivably be busier, but that's it. It's just a function of the busyness. Well, I guess you'd be talking to a few more. Yeah, okay. So during recovery, I guess you'd be talking to more other OSDs per OSD than otherwise. So, yeah. It would be worse.
Because I'm just wondering if like we compared simple messenger to async messenger when recovery is going on, whether there would be any difference.
Well, I dropped out for a moment, so I wasn't totally paying attention. But I think this is less, do we accept performance degradation in async messenger, and more, there's an obvious performance issue with async messenger we should just fix. I think we're going to still default to async.
Yeah, I think that's the right answer.
Like, we're not going to, unless we have evidence that this is some kind of unavoidable problem, we're not just going to eat it. We're going to fix it.
That's fine with me. I didn't realize you'd made that decision, so that's really helpful.
Yeah. I mean, simple messenger has so many problems that even if there is a small regression, for small clusters, people can manually choose simple.
Yeah. Thanks.
All right, well, I think that's all I've got, so I'll probably stop sharing this now. Does anyone else have anything that they want to talk about this week?
Yeah, just briefly, I'd like to mention that I've been working on running CBT via Twothology, and I'm going to start adding some more data points for the CBT to collect regarding like in different intervals for recovery, for like, for example, how long different phases of recovery are, how long different phases of peering are, that sort of thing. So it'd be kind of interested in hearing people's thoughts about other things that would be interesting to add in that sort of framework.
Cool. That's really good. Josh, do you are you using the kind of the recovery stuff in CBT, or are you doing something else through Twothology itself?
Yeah, I was planning on using the recovery stuff in CBT because I think it makes sense to have CBT just be able to do that directly.
Cool. Very cool. Yeah. One of the things that that CBT doesn't do as well as like the thrashing test is it kind of has this canned kind of recovery test right now where you can repeat it over and over again, but it's not nearly as like random as the thrashing in Twothology is. Do you think would that be worthwhile to kind of make more like the Twothology one?
Yeah, I think there are probably some things we could add to it from the Twothology side, like things like not beyond just simple like taking down one OSD, things like various kinds of other background operations like scrubbing or increasing PG count or increasing replication count, that kind of thing.
Yeah, that's what I was thinking too, because like right now it just you can take down a set of OSDs or you can take down one or whatever, but it's pretty basic, right? It does a real a subset of what Twothology can do. That would be really cool.
Cool.
Neat.
Yes,
Neat.
I think it does make sense to keep adding that to CBT since it can be run standalone as well, and it's easy enough to add that logic there.
Yeah. That reminds me, Ben, I wanted to ask you, sorry, I should be on top of this, but did you end up submitting a pull request for the monitoring changes in CBT? Oh, maybe we lost Ben.
Sorry, I pretty close to having that done, I think. I've been finishing that up, and I'm hoping to get something for you to look at today and see what you think. I basically, for people that aren't aware of what was going on there, I was doing some work to try to make the sort of the monitoring more configurable. So you could pick and choose which monitoring tools you wanted to run, by editing the CBT YAML. And to do that, I made it sort of more object oriented the way it works. And so I kind of got it part way there, but I hadn't finished it, and I'm trying to finish it up now. So does that help?
Yes. So the reason I brought it up was because I was thinking that with Josh's stuff that he's working on here, it might be useful if then he could tie into your work to basically if we were going to start playing around with like curing or other things, that then we could use that new framework you've got for actually writing monitoring for all of this, like looking at different statistics that we would maybe want to grab during these other kinds of recovery or puring or whatever it is that we would end up wanting to look at.
Right. So I mean, I think you can get the basic idea of it from looking at the I think there's something in the CBT pull request area or something that there's a pull request that's there that gives you the basic flavor of it. And so if you want to add a new monitoring tool, you just write a small class that inherits from a CBT monitoring base class, and that it's pretty simple to write that, and then you basically just have to edit your YAML to reference it, and it will pull it in. Is that what you were talking about?
Yeah. I figure that, so like right now, and at least in the when you run a recovery test in CBT, there's like some hard-coded thing that basically just like, I think runs like Ceph health or something over and over again and dumps out the lines into a flat file somewhere. But presumably we move that and any other new things over into like your framework, where it's just a module that you load that grabs health information or whatever, degraded object information from wherever we end up wanting to grab it, whether or not that's Ceph health or something better. Yeah, getting that kind of monitoring stuff moved into your framework, I think, will be really good, and hopefully we can use that for new stuff too.
Yeah. So yeah, sorry, it's taken me a little longer than I had hoped because I had to juggle a bunch of things. But so I posted the pull request that it's the sort of not totally up to date, but it gives you the basic idea of it in the chat window for anybody that's interested. And what I've been doing since then is I pulled some of the common code that's in all these different benchmarks into the the base class for benchmarking, so that it's easier to kind of make the changes that we want to make. And so I don't know if that I'll see what you think of it when I get that posted. But there was a lot of sort of repeating code in the some of the benchmarks.
Cool.
So that's it.
Looking over that briefly, it looks great. I like the way you pulled that out of the individual benchmarks and put it into a base class. Or
Good.
Common place.
I mean, it's very complicated to do this. So, I mean, if we do it, it just, we're going to have to kind of test all these different benchmarks and make sure they're still functioning. And I'm trying to do that for as many as I can. But
if we're honest, some of the benchmarks may not even be functioning right now. Like the some of the kernel RBD one gets tested so seldomly that looking at it, you'll probably make it better than it is right now, even if you're testing it at all. So
Okay.
thank you for doing that.
But yeah, I think it will make CBT a little easier to to customize for what you want to do. And,
yeah. Well,
so,
cool. Yeah, thank you, Ben, for working on that one, and thank you, Josh, for the stuff that you're looking at, because they're both going to be really, really nice. All right. Anything else, guys? All right. Well, let's wrap it up then. I imagine next week we will be probably we'll have the new looser encode decode stuff merged, and hopefully we'll know more about the async messenger stuff. So until then, have a good week, and we'll meet again next week. Thanks, guys.
take care, everybody.
Thanks, Mark.